morning friends, a very warm welcome to you all in my new session of mathematics of class 10th. Today we are going to introduce the chapter 7, which is coordinate geometry. In this chapter, as earlier you have studied in class 9th, that introductory part of coordinate geometry. In this we are studying that how to locate a point there in the Cartesian plane, means in coordinate system. So this is the coordinate system, means this two-dimensional plane. This plane is divided by 4 planes with these 2 axes, this vertical line, this horizontal line. This horizontal line is called x-axis, or you can say its other name is also, it is x-axis, or it is also known as abscissa. This horizontal axis. Now this vertical axis is called y-axis, or it is called ordinate. It is also called ordinate. Right, children? So these all are the introductory part of this coordinate geometry. So as I told you that with the help of this coordinate geometry we are locating a point in the plane. So this plane is divided by these 2 lines into 4 parts, and these 4 equal parts are called quadrant. So this is quadrant, this is quadrant first, this is quadrant second, it is third quadrant, and this quadrant is quadrant number 4. Now these 2 axes, x-axis and y-axis, are intersecting at point this, say this is O. The point of intersection of the axis is called O for origin. This is origin. Now this x-axis is represented by x, O, x dash, this is imaginary part, and this is y, O, y dash. So now this plane is divided into 4 quadrants, quadrant number 1, quadrant number 2, quadrant number 3, and quadrant number 4. Right? So here, as 4 quadrants we are having, this is as how to decide these are the quadrants, it is moving anti-clockwise. So you have to take this as origin axis, and from here anti-clockwise you have to move. So first, second quadrant, third quadrant, and fourth quadrant. So total 360 degree it revolves. Right? Now as the first quadrant, second quadrant, and third quadrant, fourth quadrant we are having, means these 4 quadrants we are getting with these 2 axes. Now let us understand the sign of each quadrant. So to locate a coordinate of a point, to locate a point in these planes, in these quadrants, we should have an ordered pair numbers, and those ordered pair numbers are called coordinate of a point. That point is always written in this form xy, means this x is the distance on x-axis and this y is the distance on y-axis. That's why always we are taking an ordered pair number, right? Now the sign of this first quadrant is always, when we are taking the sign convention, so from the origin always measure the sign. If you are measuring on x axis right side from the origin, you will get the plus sign, and left side from the origin you will get minus sign, means this is negative direction and it is positive direction. Similarly, on y axis, means on ordinate, the upward of the x axis is positive direction of y axis and downward is negative direction of y axis. They are intersecting at point O called origin, and its coordinate is always 0 0, means on x axis is 0 and y axis is 0, means we are starting to measure the distance from this origin, from the 0 point. Okay, now the sign of first quadrant, as x axis is positive and y axis is positive, so this plane is called XOY. This quadrant first plane is called XOY and its sign is plus plus. Similarly, the second quadrant, this plane is called X dash OY, X dash OY, and the sign of this quadrant first of x axis, which is negative, and on y axis, which is positive. So the sign of this second quadrant is minus and plus. Same as the third quadrant is called plane X dash O Y dash. This plane is called X dash O Y dash, and in this the sign of this quadrant is minus on x axis, minus on y axis, minus on x axis, negative on x axis, and negative on y axis also. Same as for the fourth quadrant, its name is, this plane is called XOY dash. So XOY dash is the fourth quadrant, and its sign is on of x axis positive and on y axis is negative. So its sign is plus minus. So children, keep it in mind that whatever we have revised till now, this is totally you have read in class 9th. In your earlier classes you have studied these things, you know it very well, but it was important to revise once, as we are going to study the coordinate geometry of class 10th. So introductory part of this was of class 9th, right? So similarly, few other parts we are going to discuss, that is additional in this. If you are seeing this first quadrant, so you are moving from 0 degree to 90 degree. Then in second quadrant, 90 degree to 180 degree. In third quadrant, 180 degree to 270 degree, and in fourth quadrant, 270 to 360 degree in the form of angle we are explaining. Here in this chapter, coordinate geometry, afterwards, as we have discussed, we are locating a point in these planes. So x is positive, y is positive, so this point lies in the first quadrant. If x is negative, y is positive, so that point lies in second quadrant. Similarly, if negative negative you are getting in third quadrant, and if positive and negative you are getting the ordered pair numbers, so that point lies in the fourth quadrant. After seeing the introductory part, let us discuss few important that we have already discussed in 9th class also and in 10th class also in your previous chapters, like pair of linear equation in two variables, quadratic equations, polynomial, in these chapters we have discussed those things also I am going to introduce here in this coordinate geometry. So dear, as you have discussed the equation of x-axis, this is x-axis. What is the equation of x-axis? The equation of x-axis is always y is equals to 0. Why y is equals to 0? Because when you locate any of the points on x-axis, so the ordinate value of this axis will be always 0. That's why the equation of x-axis is written in y is equals to 0. So similarly, the equation of y-axis is x is equals to 0. Why? Because when you locate any of the points on x-axis, so the abscissa coordinate will be always 0. It means when you locate any of the point on y-axis, so that point always in this form, 0 and y form, means the x values will be always 0 and y can be positive upward, can be negative downward. So similarly, when you locate a point on x-axis, so वो भी हमेशा x और y x और 0 फॉर्म में मिलेगी. किस पे? ऑन द एक्सिस आई एम टॉकिंग. जब आप x एक्सिस पे किसी भी पॉइंट को लोकेट करोगे तो उस पॉइंट का कोऑर्डिनेट हमेशा x 0 फॉर्म में मिलेगा. मीन्स x की वैल्यू रहेगी समथिंग बट y विल बी ऑलवेज 0. बेस्ड ऑन दिस y इज इक्वल्स टू 0, द इक्वेशन ऑफ दिस लाइन इज y इज इक्वल्स टू 0. Right? So similarly, as the form of a point on y axis is always 0, y means x is equals to 0, therefore the equation of y axis is always x is equals to 0. Okay children, this you have discussed. Now you have discussed the equation of lines parallel to the axis. Suppose a line is drawn parallel to the x-axis. So x-axis is this one, horizontal line. A line is drawn which is parallel to this x-axis. So always the equation of this line will be y is equals to b, or this b can be positive or negative form. If it is positive plus b, so it will be upward, and if it is negative, so it will be downward. Means y is equals to minus b. Right? Similarly, the equation of a line parallel to y axis will be in this form, and this can be written as x is equals to plus a in the positive direction, and if it is in this direction, in the negative direction, so its equation will be x is equals to minus a. Right children? As you have read, in pair of linear equations to two variables, if an equation is in this form, ax plus by plus c is equals to 0, so this is the equation of a straight line in any of the direction. This is ax plus by plus c is equals to 0. This is always a linear equation, or you will get always a straight line. As it was given pair, so you are getting two equations, like such as in second chapter polynomial you have read a quadratic equation, and the equation of a quadratic equation, that quadratic polynomial ax square plus bx plus c. The graphical representation of this quadratic polynomial is always a parabola. Why? Because it is having a second degree. Px is equals to ax square plus bx plus c, and this equation is of this parabola in any of the direction. It can be in this direction also, it can be in this direction also. Right? Afterwards, after completion of this introductory part, we are going to discuss the distance formula, which is very important for this chapter, coordinate geometry. See the proof of it properly and very carefully, right? Now friends, let us discuss the distance between 2 points from this figure. So let us find the distance between 2 points P, and the coordinate of point P is x1, y1, and the second point is Q, whose coordinate is x2, y2. Okay, so to find the distance between these 2 points, say this is the point P and its coordinate is x1, y1, and this point is Q, its coordinate is x2, y2. So we are going to find out the distance between these 2 points, means the distance between P and Q. We are going to find out the distance between P and Q. So to find the distance between these 2 points P and Q, we need to draw a line segment PR such that this line is perpendicular on x-axis. So PR is the line perpendicular on x-axis from the point P, and QS is the line drawn from the point Q perpendicular on the x-axis. Perpendicular, this is QS. So draw lines PR and QS such that PR is perpendicular such that they both are perpendicular on x-axis. Perpendiculars on x-axis. Right? So dear students, as these perpendicular lines we have drawn, so the measure of this PR will be y1, because it is the distance on y-axis, and the coordinate of point P is given x1, y1. Same as the length of this one QS will be y2, right? So draw a line, this is y2. Draw a line P2, that PT is perpendicular on QS. We have drawn this line PT, which is perpendicular on QS, and also draw PT is perpendicular on QS, right? As the measure of PR is y1, measure of QS is y2, similarly the measure of OR is x1 and the measure of OS is x2. This is the measure of OS and it is the measure of OR, right? So from the figure it is clear that It is clear that PR equals to Y1, QS equals to Y2, OR is equals to X1 and OS is equals to X2, right? Afterwards, as OR is equals to X1 and OS is equals to X2, so can we find the measure of RS? This RS can be written as X2 minus X1. The measure of this RS can be written as X2 minus X1. Similarly, if RS is X2 minus X1, so the measure of PT is also will be written as X2 minus X1, right? Similarly, if this PR is Y1, therefore TS will be also Y1, so the measure of QT will be written as Y2 minus Y1. Okay, so therefore from the figure it is clear that measure of RS is equals to X2 minus X1 and measure of QT is equals to Y2 minus Y1. So since we are getting here a right angle triangle Q, T and P. P, Q and T is a right angle triangle at point T. So triangle PQT is right triangle at T. So as it is a right angle triangle, so we can apply the Pythagoras theorem. If it is a right angle, so this PQ is hypotenuse of it, this is perpendicular and this is base. So from the Pythagoras theorem you can write it PQ square equals to PT square plus QT square. So PQ square, that we are going to find the measure of it. Measure of PT is X2 minus X1, X2 minus X1 whole square plus measure of QT is Y2 minus Y1 whole square. Therefore measure of PQ came, which can be written as square root X2 minus X1 whole square plus Y2 minus Y1 whole square, or it can be written as under root X1 minus X2 whole square plus Y1 minus Y2 whole square, which is your required distance formula. That is the important part of this coordinate geometry, we got it. So the distance between 2 points PQ is equals to under root x2 minus x1 whole square plus y2 minus y1 whole square, or this formula can also be written as under root x1 minus x2 whole square plus y1 minus y2 whole square, which is the distance between these 2 points. Okay friends, see the remarks which is based on the distance formula that we have discussed already. What is the remark? That basic things, you just see there are 2 points are given. First, it is given in particular, if you are going to find out the distance of a point P whose coordinate is xy from the origin, so this is the distance between P and O, means OP can be written as under root x square plus y square. This formula you can get from your general formula that we have discussed. PQ is equals to x2 minus x1 whole square plus y2 minus y1 whole square. Now see the second remark, what is given? This formula PQ can also be written as x1 minus x2 whole square plus y1 minus y2 whole square. There in your textbook it is given. Why? Reason. So reason is that if you are writing x2 minus x1 and x1 minus x2, why it is taken both are right? Because the square of this number. So if you are taking x2 minus x1, then x1 minus x2 will be negative, and that negative becomes positive with this whole square number. That's why both the formula we are studying PQ is equals to under root x2 minus x1 whole square plus y2 minus y1 whole square is equals to x1 minus x2 whole square plus y1 minus y2 whole square also. So I think both the remarks clear, and the reason behind this formula also is clear to you all. So what is the reason? Because of this square, both the formulas are accepted, right? Let us see the example number 1 of your textbook just after the explanation of the distance formula. Here it is given, do the points 3, 2, minus 2, minus 3 and 2, 3 for a triangle that form a triangle. It is given these points form a triangle, we are going to decide it. Do these points form a triangle? If so, name the type of a triangle so formed, right? So to find in the solution, let us apply the distance formula to find measure of PQ, QR and PR such that point P is 3, 2, point Q is minus 2, 3 and point R which is 2, 3. Okay, so to find the measure of PQ, as we have the formula under root x1 minus x2 whole square. So here this is x1, this is x2. So under root x1 minus x2 whole square or x2 minus x1 whole square minus 2 minus 3 whole square plus y2 minus y1 whole square minus 3 minus 2 whole square. So this is equals to under root 3 to 5, 5 5s are 25 plus 25 and 5 5s are 25, which is equals to under root 50, right? Same as find the measure of QR. Q minus 2 minus 3 are 2 and 3. So under root x2 minus x1 whole square. So 2 plus 2, it is minus, so minus minus plus 2 whole square plus y2 minus y1 means 3 minus minus plus 3 under root 2 2 4 4 4 is 16 plus 3 3 6 6 6 are 36, that is equals to under root 52, right? And find the measure of PR also. P and R we are taking. P is x1 y1, R is x2 y2. It means x2 means 2 minus 3 whole square plus y2 minus y1, 3 minus 2 whole square, which is equals to under root 2 minus 3 is minus 1 whole square, which is 1, and 3 minus 2 is 1, 1 square is 1, that is under root 2. Now see the values of this root 50, which is equals to approximately 7.07. Square root 52 is 7.21, which is approx, it is also approximately, and this is under root 2 is 1.41 is approximately 1.41 is approx. Okay, now after getting these values, these measure of the sides of this PQ, QR and PR, this is 7.07, this is 1.41. So the sum of these two sides PQ and PR is greater than this third side QR. So here we observe that PQ plus PR is greater than QR. Means PQ, measure of PQ is 7.07 plus PR is 1.41, that is equals to 7184, means 8.48, and measure of QR is 7.21. Therefore we are getting PQ plus PR is greater than QR. Therefore these points PQR, means these points 3 2 minus 2 minus 3 and 2 3 form a triangle. Therefore points PQR form a triangle. Now after this question is asking, if so, it is clear that they form a triangle they are forming. So if so, name the type of the triangle formed. Now we are going to decide which type of triangle it is. So let us see, the largest side of this triangle is under root 52. Okay, the largest side of this triangle QR is under root 52. So here we are observing that QR square equals to QR square equals to PQ square plus PR square plus PR square. Just see, is it following? This is under root 52 whole square plus this is root 50 whole square plus PR is root 2 whole square. So this is 52 equals to 50 plus 2, therefore 52. It means it is following this Pythagoras theorem. Therefore PQR is a right angle triangle. PQR is a right triangle. Okay, so first we have decided that this is a triangle. After getting this decision that this forms a triangle, which type of a triangle? It is right angle triangle, because this is following the Pythagoras theorem. Okay.